Hello students, and welcome to your how-to video for your covalent bonds Gizmo. Now once you get the Gizmo loaded and you're logged in, this is what it will look like. You'll notice we have two atoms here to start, and each atom is fluorine. Now I'm not going to do fluorine for the example, however I am going to do water to show you how to use this Gizmo. Now you'll notice select a substance up here that I already clicked on, and I can go all the way down to whatever it is that I'm choosing to do. Now remember, you only have to do 4 substances you pick out of the list given in the table. So in your first row, you'll pick just one. In the second row, you'll pick one, but it has to be a different one from what you did before. The third and fourth row have bigger molecules. You'll notice water is not an option, and that is because I am doing that as the example. So once you get your substance selected, it'll pop up on your screen with however many atoms you have. And you're going to want to select Show Lewis Diagram, and you're going to also want to select Hide Inner Electrons. Now, the reason why I hide the inner electrons is because it hides these electrons here, which is less confusing for you, and then it only leaves out our valence electrons, which is what performs chemical bonding in the first place. The reason why I left the Lewis diagram on there, even though we don't do much with it, is because, again, it's a diagram that can help guide us on what we're supposed to do. Now, if we can remember from the meeting, on a Lewis diagram, we have the elements that are in our molecule, and the bonds are represented by lines. So you'll see there's a line in between this oxygen and hydrogen, and there's also a line between this oxygen and this hydrogen. That line represents a shared pair of electrons that make up a chemical bond. Since those electrons are shared, they are part of oxygen as well as they are a part of hydrogen. And when you notice the word pair, that means there's 2. So each line represents a pair or 2 shared electrons. So I have 2 shared here and 2 shared here. And then I have dots on the outside of oxygen. Those dots represent unshared pairs of electrons, which means they are not part of a bond. They're just part of oxygen. So how can we make these bonds over here using the atoms we're given? So if we start with this hydrogen and this oxygen, you'll notice there is a shared pair, which means we have to have 2 shared electrons between this hydrogen and this oxygen as well. I can do that by clicking and dragging my electron to the element or atom I want to share it with. So you'll notice that that created this oblong shape. Now, that is just one shared electron. Remember, you have to have a shared pair. Since hydrogen has only one electron it can share, that means the other electron has to come from oxygen because we can't share it with anything else. So if I share it with my hydrogen here, you'll notice it moved over by the other hydrogen electron, and that's because electrons like to move in what we call pairs. So that creates that covalent bond between hydrogen and oxygen. Now, if I were to hit play, I could see this shared pair as it moves along this pathway. And then I can pause it, so it helps me know what's shared so far and what isn't. Now I have to make one more bond because oxygen has 2 bonds. You notice 2 lines. So I'll do the same thing here with this hydrogen. I have that 1 valence electron. So you'll notice once I moved that valence electron over, it created this new pathway. Since I can only have 1 valence electron from hydrogen, that means another valence electron has to come from oxygen. That's the only way you're going to get a shared pair. And you'll notice that I have a couple to choose from. I'm just going to grab this electron here. And I chose from that one, and now I have this shared pair of electrons for this bond as well. So now if I hit play, I should see the pair that I had originally continue on that path for that bond. And now I have 2 new shared electrons, and you'll notice they're shared because they're spending time with both nuclei. So you have them rounding hydrogen and rounding oxygen. And that's going to be your covalent bond. Now, if I wanted to count to make sure this was stable, hydrogen should only have 2 valence electrons because it's super small and has only 1 energy level. And we'll notice it has 2 electrons that it shares right here. And this one also has 2 that it shares here. So both of them have 2 valence electrons, part of that shared bond, and that meets that rule of stability. Now for oxygen, it has 4 singular electrons moving around it all the time. And then it has 2 shared from this hydrogen on the left and 2 shared from the hydrogen on the right. So that means it has 4 plus 2 is 6 plus 2 is 8. So this oxygen meets the octet rule simply because it's sharing those electrons with hydrogen. And that's where you get that stable bond, by having oxygen having 8 or a full outer shell, as well as hydrogen having that full outer first energy level, which only holds 2 electrons. Now if you want to check, which is what you have to do, you'll hit this check button and it'll tell you, yay, you got it right. Now when you take a picture of this as your screenshot, I want the whole thing included. So you're going to want to take a screenshot of your model here, the substance you did, the Lewis diagram, as well as this feedback. And that's going to be what I need in order to give you that full credit. Now when you're ready to do a different element or compound, you hit pause and then reset, and that'll bring you back to the starting point where you can then select different substances based on what you want to do. So that's how you do the lab. If you have any questions, make sure you email me or meet with me. Otherwise, good luck, and then when you're ready, move on to the next assignment.